Okay, so lately there have been a lot of questions surrounding the topic of opaque behaviors and default values and simulating different value properties to store information. So this video is going to be dedicated to kind of going over the problem with that and a solution. And this is a very basic version of what I presented in 2024 at the NCOSE International Symposium. So the need here is to be able to run a simulation that parses the model, calculates a value from a structured expression, and returns that information during runtime. The problem is structured expressions. If you want to use a structured expression, they're not compatible with the default values. Um, and in this case, we're going to be using an opaque behavior in conjunction with that, and these need to be expressed in order to run. And therefore, we need to either run a macro or a simulation in order to express that behavior. We can show both here. We're going to be focusing on the simulation a little bit more though. So the solution. We're going to use parametrics to express the opaque behavior in order to get a map value from a map key that we pass in during simulation. So if we look over here, we have a block sum of default values context, and we have P1, P2, and P3. These are value properties. These are integers. The first two have default values 1 and 2. And what we want to do is we want to have a sum value for P3. So in order to get this done, we need to first have an opaque behavior. So the opaque behavior that we have here is this VP sum, stands for value property sum, and then we have a map key input. The reason why we have a map key here is because in this case, in order to get these things working together, we need to establish a map in order to store values because we are parsing the model. We're going to be going to this element, this value property, getting its value, and then adding it to this value, all within a simulation and not just within one script. We're going to be doing it within a structured expression. So that structured expression has to go and parse these values and then store that data somewhere, and then we have to access that data. So what we're going to do is we're going to open this, and we have just a very simple map called getSum, and this is the map key. And then the map value is just going to be arg1 plus arg2, and we can see in the structured expression that is defined for this that arg1 and arg2 are indeed these value properties here. And then arg3 is the map key. So let's go back to our example here. So arg1 is that value property, so we're going to get the default value. Then we have to get the value from that default value and then change it to an integer because of the context of where it's at within a structured expression. So then we're going to add these two values together, and that will be our map value. And so we need to, in order to get that map value as a return, we need to call getSum. We need to give that key. So immediately we call ourselves at the end of this. So sum map. And the reason this is important is because in the simulation, we are going to run this map, and then we are going to call ourselves, and we're going to pass in this getSum. So where do we do that? So this is where we move over to a constraint block. So this constraint block is right here. It's called getSum. So we have this, again, we have these two integer values. that are being passed in, and then we have a sum that's being passed out. And then we have this constraint. So in the middle, this constraint is saved right here. And in this constraint, this is a block of code that's been rewritten. There's a lot of comments, so it might look like it has a little bit more information, but it's actually it's pretty simple. This was rewritten from the automated trade study, where I took Saulius's automated trade study model, and I used this methodology to be able to parse values from the instance tables and provide them real time. So in case those instance tables were updated, we didn't have to do some manual calculations for the best and worst case values, which is what we originally had to do. So to repurpose this, we didn't have to change much, just some values down here, but I'll go ahead and go over this code. So the first thing that we have to do is these import statements. So for the import statements, we're only using these, we're using application so that we can actually use both the log and so that we can get the project, so that we can search that project. The next one we have is the expression helper. We need this expression helper in order to actually call the opaque behavior. And then we're using the finder tool to actually search the model. Okay, so the next line is just defining L to be the GUI log. That way that we can, at the end here, we can call the log and save the value that we get to it so that it will actually pop up in our notification window. The next portion is we want to define a variable to hold the opaque behavior class so that we can use it in the finder helper below. So we have this opaque behavior, and then we are just saving the class to it. This can all be found in the Open API. Define a project variable for use in the Finder helper below. So we save project here. It's just an instance of our project. And then we're going to define an empty object to be set inside for the loop below and called after. So this is just an empty element. And then for the found elements, we are just going to get the required behavior and then find all those types recursively. So what we've done here is this is finding all of the opaque behaviors in the model and saving them to found elements. And then we're going to loop through. So for each one of those opaque behaviors, if the name is equal to VP sum, which if you recall is the name of our opaque behavior, then we want to save it to Ellie. And then, I'm sorry, not Ellie, element. And then we want to go ahead and express the opaque behavior that we found above. So here, and we're saving it to this behavior expression. We're using that expression behavior, and we are expressing that opaque behavior. So once we do that, the last step is actually to call now that behavior, and this is where we pass in our arg3. If we remember from this arg3 here, this is where we're passing it in. So in that constraint block here, where we go through this constraint, we actually are passing this getSum, which is that arg3, and that's going to be the map key, and then it's going to return that value, in this case 3, to us, and we're going to save that to sum, and then we're going to print that to the screen. And at the same time as we're printing it to the screen, we're saving it to this constraint parameter sum, and it's saving that to P3 here. And we can see an example of that by simulating this here. And we can see that we have 1, 2, and 3, which is the final sum of these first two integers. 1 plus 2 equals 3.